Okay, I'm going to go over problems 1 and 2 for the Unit 4 test review. Question 1, which coordinate represents the solution for the system of equations? As you can see, they're both in slope-intercept form. So this will be simple to plug in x and a y value to see if we get true statements. Now, if we want to know if something is a solution, we plug it in and check to see if it makes a true statement. So let's check A on the first one. So we're going to plug in 2 for x, 5 for y into the top equation. So if I do that, I get 2 times 2 plus 5, and this should all be equal to 5, because that's my value for y. 2 times 2 is 4, so I get 5 equals 4 plus 5, and I can already tell you that it's not going to be true. 4 plus 5 is not equal to 5. So we know it's not A. Cross A out. So let's plug in 3 for x and negative 1 for y. Now I don't have to plug it into the second equation because it's already not true for the first. It has to be true to both to be a solution to the system. Alright, so we get 2 times 3. Negative 1 equals 2 times 3 plus 5. 2 times 3 is 6, so I get negative 1 equals 6 plus 5. I can already tell you 6 plus 5 is 11, so that one's not going to be true. So we know B is not true. Let's plug in negative 3 and negative 1. So I get negative 1 equals 2 times negative 3 plus 5. So 2 times 3 is negative 6, so I get negative 1 equals negative 6 plus 5. And I get negative 1 equals negative 1. Alright, so it's true for the first equation, but we do need to plug it into the second equation to make sure it's also true for the second equation. So I get negative 1 equals negative 3 times 3 minus 10, plugging it into the second equation. And negative 3 times 3 is negative 9 minus 10. Negative 9 minus 10 would be negative 19. Negative 1 is not equal to negative 19. So it's not true for the second equation, which means it's not true for this system. So we're going to check the final one. We're going to plug negative 1 in for x, 3 in for y. So I'm going to plug it in the top equation. I have 3 equals 2 times negative 1 plus 5. 2 times negative 1 is negative 2, so I get 3 equals negative 2 plus 5. Negative 2 plus 5, that would be correct. So let's plug it into the second equation. So I get 3 equals negative 3 times negative 1 minus 10. Negative 3 times negative 1 would be positive 3. 3 minus 10 equals 3, so 3 minus 10 would be negative 7. 3 does not equal negative 7, so it is not true for the last one either. I'm going to double check the first one to make sure I didn't make an error on the first one. And first one is correct. Let's double check the second one, B. That one's also correct. Plug in negative 3, you get negative 6, boom. Negative 3, you get positive 9. Positive 9 minus 10. Okay, I made an error on the second one. Or C, part C. It is C. My error was plugging it into the second equation here, so I got negative 1 equals negative 3 times 3 minus 10. This is where I made my error. Negative 3 times 3 is negative 9. But I was supposed to plug in negative 3. So that was my error. That should be a positive 9, which does equal negative 1 when you have 9 minus 10. So that answer is correct. It'd be C. Okay, for number 2. Hello? Good morning. So where these two are equal to each other is B. The y-intercept for f of x is D. The x-intercept for g of x is C. In the points where f of x is less than g of x. So f of x is less than g of x here. So it'd be D and E.